Good day, respected faculty of Liverpool John Moore University, examiner, and colleagues. My name is Abdul Nadeem Mohammed, and it is my honor to present my master thesis in data science entitled Business Cycle Dynamics, a managerial framework for economic trend analysis and expansion strategies using artificial intelligence. This research emerged from an urgent question that faces today's economists and business leaders. How can artificial intelligence driven model forecast complex business cycle with greater accuracy, transparency, and interpretability than traditional methods? In an era characterized by pandemic, geopolitical conflicts, and global technological transition, economic uncertainties has become a defining feature of global market. Conventional forecasting tools such as ARIMA, VAR, and DGSE often struggles to capture these nonlinear and interdependent dynamics. By contrast, modern AI techniques, particularly deep learning and ensemble models, offer the ability to learn pattern from large multi-source data stream in real time. Therefore, the central focus of the study is to develop a hybrid explainable AI framework that can predict business cycle turning points and economic trend with both precision and managerial interpretability. Over the next 20 minutes, I will guide you through six main sections: the introduction and background of this research thesis, a concise literature review, the problem statement, the research methodology, and a presentation of how results and discussion, and finally, the conclusion and the future direction that highlights the study, academic, and managerial contribution. Let us begin by exploring the background and motivation that underpin this research. In this slide, the challenges of economic uncertainty. The global economy today operates under condition of unprecedented uncertainty. Over the past decade, a series of overlapping crises ranges from pandemic and geopolitical conflicts to supply chain disruption and energy price shocks. How expose the fragility of traditional forecasting system? These events has fundamentally altered the rhythm of business cycles and reliability of economic prediction, depending more adaptive and intelligent approach. Number one, global volatility. Pandemics such as COVID-19, trade wars, and ongoing geopolitical tensions have triggered extreme market fluctuation, disrupting trade routes, production network, and capital flow. Such shocks are not isolated. They occur simultaneously across interconnected economic produce feedback loop that amplify volatility. This degree of global synchronization means that every localized disruption, whether in commodity supply or logistics, can quickly cascade full scale macroeconomic instability. Number two, traditional model limitation. Historically, economists have relied on models like ARIMA, VAR, and DGSE to interpret and predict economic activity. While these models provide valuable structure and theoretical grounding, they depend heavily on assumptions of linearity, equilibrium, and stationarity. In practice, this assumption rarely holds during crisis. Economic system exhibits nonlinear regime shifting behavior. When relationship between these variables evolve, unpredictability under stress, as a result, conventional models often fail to anticipate sharp turning points or sudden structural change. Precisely, such accurate forecasts are needed most. Real-time decision need. In such volatile environment, managers and policymakers face mounting pressure to make rapid data-driven decision, whether it is adjusting physical policy, rebalancing portfolios, or realigning supply chain. Timely intelligence is critical. However, traditional models operate primarily on logged or quarterly data, offering limited responsive or fast moving global event. This context underscores the central motivation of this research to design an AI augmented forecasting framework capable of assimilating real-time multi-score information and generating transparent, adaptive, and actionable prediction for decision makers operating in uncertain economic landscapes. AI revolution in economic forecasting. The emergence of artificial intelligence has initiated a paradigm shift in the way economists policymaker, and financial analyst forecast business cycle and interpret macroeconomic dynamics. Traditional econometrics model rely on fixed mathematical assumption and limited data inputs. But AI offers a new dimension, learning directly from complex nonlinear patterns with massive multidimensional datasets. Number one, machine learning advantage. At the core of this revolution, an advanced architect such as long short-term memory LSTM network and ensemble learning models like XGBoost and LightGBM. This system possess the ability to capture long-term temporal dependencies and non-linear interaction that conventional model fails to recognize. Recent empirical studies include those by having demonstrated the LSTM network can outperform classical autoregressive model by approximately 25% in forecasting accuracy. This has been justified by the previous research and particularly during volatile or crisis period when traditional models often collapse. This superior performance stems for AI adaptive learning mechanism in it is continuously refines parameter based on new data, mimicking new economic condition evolve over time. Number two, multi-source integration. A critical advantage brought by AI lies in its capacity to integrate multiple data modalities. Unlike traditional models that depend solely on structured economic indicators such as GDP, inflation, or interest rate, AI framework can incorporate unstructured data, including news, articles, financial reports, investor sentiments, and even social media signals. This multi-source integration allowed the model to sense early signals of policy shift, market sentiment change, or geopolitical tensions before they manifest in official economic data. By doing so, artificial intelligence transform forecasting from retrospective analysis into a forward-looking sentiment-aware system. So basically, it is like a forward-looking sentiment-aware system. Number three is real-time processing. Finally, AI computational advantage enables real-time data ingestion and analysis through high-frequency data stream. These systems can process and react to new information almost instantaneously, providing policymakers managers with timely insight of strategic decision making. In fast-changing market, these responsive is valuable and turning forecasting from a periodic reporting activities into a continuous decision support process. In summary, the AI revolution is economic forecasting represent more than just an upgrade in technology. It is a conceptual transformation. It emerged economic theory with a machine intelligence allowing forecast to be dynamic, adaptive, interpretive, redefining more uncertainty is which is understood and managed in modern economics. Research objective. This slide outlines the three core objectives that forms the foundation of this research. Each objective has carefully designed to address specific theoretical and practical gaps identified in the literature of economic forecasting and uncertainty modeling. The first objective is to design and develop a hybrid predictive framework that merges deep neural network and explainable machine learning techniques. This hybrid model aims to capture both temporal dependencies both by LSTM network and nonlinear feature interaction through ensemble learning such as XGBoost and LightGBM. By doing so, the framework ensures robust and adaptive long-term business cycle forecasting capable of handling complex, non-stationary, and high-frequency economic data. Unlike traditional economic trick methods, this model does not rely on rigid assumption of linearity or equilibrium. Instead, it learns dynamically from data, allowing it to adjust to evolving market structures and policy shift. Objective number two, multilingual sentiment analysis. The second objective focuses on unstructured textual data from diverse sources, including financial news, policy reports, and social media to measure economic uncertainty and sentiment in real time. To achieve this, the study employs natural learning process NLP techniques to extract sentiments indicators across multiple languages. capturing region-specific narratives and investor confidence level. The development of this theme-based sentiments indicates, for example, distinguish between physical optimization, trade anxiety, technological innovation, enables a more nuanced understanding of uncertainty. This approach enhances forecasting accuracy by incorporating the emotional and behavioral dimension of market participants, elements often invisible in purely numerical model. Objective 3. The third objective extend beyond model development or evaluate the frameworks generally across multiple economic and industrial contexts. Economic cycles differs in amplitude, duration, and responses depending on regional policies, industrial composition, and monetary regimes. Hence, cross-country validation ensures that proposed model is not limited to single market case but demonstrate scalability and robustness across diverse environment. This validation across provide policymakers and business leaders with confidence that systems can be adapted for strategic planning, policy formulation, and macroeconomic surveillances in both advanced and emerging market. In essence, these three objectives collectively advances the central aim of this thesis to establish an AI-driven, interpretable, and globally adaptable forecasting framework, thus enhances both analytical accuracy and managerial decision-making under economic uncertainty. Problem statement. This research began by addressing one of the most persistent and complex challenges in modern economic, the accurate forecasting of business cycle and raising global uncertainty. Over the past decade, global markets have become increasingly unpredictable. Factors such as pandemic, geopolitical tension, supply chain disruption, and inflammation of shocks have intensified volatility and blurred the distinction between cyclical fluctuation and structural transformation. These overlapping crises have made it significantly harder for policymakers, investors, and firms to anticipate economic turning point with confidence. One of the major issues that currently investors are facing is economic unpredictability. Increasing nonlinear and interdependent nature of global economic system. Unlike the relative stable patterns of earlier decades, today business cycle exhibit abrupt regime shift. Relationship between macroeconomic variable suddenly in response to shock. Number two, limitation of classical models. Classical econometric models such as ARIMA, VAR, and DGSE has long served as a foundation of macroeconomic analysis. However, these models operate under simplifying assumption of linearity, equilibrium, and time variance, which breaks down during crisis. Even though they provide interpretability and theological rigor, their predictive accuracy declines dramatically when faced with high uncertainty, structural breaks, or nonlinear feedback loop. Similarly, early generation machine learning model, while more flexible, often fail to outperform these classical approach because they lack economic interpretability and systematic hyperparameter tuning. Number three, methodological gap in current techniques. Existing forecasting techniques frequently rely on single source uncertainty indices such as new based policy or based measure, ignoring the broader ecosystem of cross-domain signals and influence economic dynamics. In summary, the core problem this study seeks to resolve is lack of unified, interpretable, and data-rich forecasting framework capable of integrating multi-source uncertainty indicators while maintaining both accuracy and transparency. This gap underscores the need of an AI-augmented hybrid model that not only predicts economic cyclic effectively but also provide explainable insight to support tragic data-driven decision-making in uncertain global environment. Gap in the current research. Our key research has identified certain gaps, detailing review of contemporary literature on economic forecasting, uncertainty measurement, and artificial intelligence application in macroeconomics. Despite rapid advancement in data science and computational modeling, several limitations persist in current forecasting approach, which the study seeks to address. Number one, limited cross-national applicability. Most existing studies has focused narrowly on single country data sets, often emphasizing major economies such as China, the United States of America, or the European zone, which such studies provide important localized insight. Their generalizability remain limited because economic structures, policy mechanism, and institutional behavior have significantly grown across the region. This gap identified the need of a global adaptable framework, one that can account for cross-national heterogeneity and provide comparative insight applicable to both advanced and emerging economic. Number two, underutilization of real-time unstructured data. A major gap lies is the unexploitation of real-time unstructured data, which such as financial news, policy reports, and social media sentiment. While these data set across rich carry risk signal of uncertainty and investor behavior, traditional model rarely incorporate them due to challenges in text preprocessing features, extraction, and sentiments. Forecasting model often overlook forward-looking and behavioral indices, relying instead on lag numerical data that fails to capture evolving market narrative. Number three is the weak exploitation of interaction and causality. Another key limitation is the lack of research exploring the interaction of causal relationship between uncertainty indices and macroeconomic variables. Many studies treat uncertainty as an exogenous shock rather than an integrated part of economic system. This result is fragmented understanding of how uncertainty actually influences production, investment, and consumption decision over time. This research aims to overcome this gap by embedding uncertainty as a dynamic endogenous variable within the predictive modeling. Number four, insufficient model explainability. Uh, Often in AI-driven forecasting, often focus on global interpretability, providing high-level model explanation over granular or context-specific insights. This limits usefulness is in policymaking, where decision-making require transparent case-level interpretation to justify action and allocate resources effectively. By integrating SHAP and LIME AI techniques, this study enhanced both globally and local interpretability, bridging the gap between complex AI model and human-centered economic reasoning. In summary, these gaps collectively emphasize the need of comprehensive, interpretable, and multi-source AI forecasting framework capable of overcoming methodological context and eliminating ethical existing research. Justification of the study. The justification for undertaking this study emerges from the growing disconnect between the complex realities of global economic system and the limitation of existing forecasting model. Modern economics operates in an environment defined by high volatility, data heterogeneity, and rapid information diffusion, depending on the forecasting approach that adaptive, transparent, and data-driven. Number one, in the current global context, economic cycles have become more erratic, given by a convergence of structural and behavioral forces. Events such as pandemic, trade war, inflation shock, and geopolitical instability have increased the frequency and intensity of the regime shift. These shifts are further amplified by emergence of high-dimensional, multi-source and multilingual data system encompassing both structured economic indicators and unstructured information from media, policy documents, and social sentiment. Traditional models such that rely on statistic relationship and that are incapable of capturing these nonlinear dynamics or responses to rapid change market. Number two, which is managerial policy imperatives, where the business manager's timely and reliable forecast are essential for formulating strategies, responses to economic uncertainties. Again, they require nimble and interpretable forecasting framework system and capable of processing multi-source uncertainty indicators while maintaining transparency in their decision making. However, as I understand, AI model, despite their predictive strength, functions as black boxes offering limited interpretability and minimal support for managerial insight. This lack of transparency undermines their practical application in policy formulation. investing planning, and risk management, where accountability and trust are paramount. Number three, what I understand is that to address these challenges, this study proposes the development of a transparent hybrid AI framework that unites three critical capabilities. Number one, which is the multi-source uncertainty integration that combines structured and unstructured data for the strategic decision making, featuring selection and multi-object optimization for enhanced model efficiency and accuracy, explaining through SHAP and LIME to ensure that the interpretability to both global and local level. So by aligning all these machine learning sophistication with economic transparency and interpretability, this research bridge a crucial methodological gap. The result framework not only improves the decision of business cycle prediction, but also deliver decision support tools that policymakers and managers can confidently rely in uncertain macroeconomic environment. In an essence, I understand that this study is justified by its potential to transform AI-driven forecasting from purely computational exercise into explainable, trustworthy, and managerial intelligence. Methodological overview. So this slide provides a comprehensive overview of research methodology summarizing the four main stages that structure the entire analytical process. Number one, which is the data extraction. The first stage involved data acquisition from one of the key Yahoo Finance using the vFinance library covering historical market data of Tesla, company Tesla between 2010 to 2024. Tesla was chosen as a representative case due to its innovation driven volatility and responsive to macroeconomic event, making it an ideal proxy for understanding cyclic and behavior dynamics in global finance market. The data sets include key financial indicators such as opening, closing, high, low prices along the tradition volume and derived market ratios, providing both trend and volatility perspective. This foundation ensures that the model captured not just temporal market fluctuation but also underlying behavior signals influencing price movement. Number two, which is key, is the data processing. The next step, what we did is a data cleansing and preparation, a critical phase ensuring that model reliability and computational efficiency. Process include handling missing values, outlining detection and treatment, categorical encoding, and data normalization to align the variable scales of optimal learning. Features engineering was used, then applied by Bayesian regularization, LASSO, BRLASSO, to identify the most statistically significant predictor while reducing noise and multi-collinearity. By optimizing the quality of the input data, and the model achieved improved stability and convergence during training. So model development. At the core of methodology is the hybrid model architecture, which combines the strength of BiLSTM, XGBoost, and Light GBM within a unified predictive framework. Bidirectional long short-term memory, which captures the sequential dependency, clinical cyclical momentum, and long stage temporal pattern in the time series data. XGBoost, which contributes to the robust gradient boosting for nonlinear features, interaction, and noise reduction, and then Light GBM functions as the meta learner, integrating output from previous layers and enhancing overall generalization. So the model training process was optimized through a NSGA algorithm, non-dominant sorting generic algorithm, a multi-objective optimization technique that fine-tune hyperparameters to simultaneously minimize mean square error MSE and mean absolute error MAE. These ensure that both accuracy and stability across multi-forecasting horizons. And then finally is the research integrate, which is the explainable artificial intelligence tool SHAP, and LIME, which is shapely additive explanation and local interpretable model agnostic explanations. These tools were employed to interpret both global feature importance and local decision behavior within the model. This layer of explainability transforms what would otherwise be a black box into a transparent analytical system, enabling researchers, managers, and policymakers to understand why a particular forecast was made. In summary, this methodological balance technical sophistication with interpretability and ethical AI practices, ensuring that the forecasting framework is both significantly rigorous and practically applicable for real world decision support. Hybrid model architecture. So this slide provides the core architecture of the proposed hybrid AI-driven forecasting framework, which integrates deep learning, ensemble learning, and multi-objective optimization to achieve robust, accurate, and interpretable economic forecast. The design of this model draw open the principle that no signal algorithm can effectively capture the entire spectrum of temporal, nonlinear, and stochastic behavior that characterize modern economic system. Therefore, the hybrid structure strategically combines multiple base learners with complementary strength integrate within an adaptive optimization framework. Base learners, which is the by LSTM, and they serve as the integral temporal features extractor. Unlike traditional LSTM, which process data into the single direction by LSTM analysis, time series sequence in both forward and backward direction, capturing long-term dependency and cyclical relationship more comprehensively. This dual perspective is particularly vital for detecting turning points in economic cycle as it allows the model to account for both past influences and emerging future trends simultaneously. XGBoost that handles the functions as the secondary learner responsible for modeling the nonlinear interaction and complex featuring dependency that by LSTM alone may overlook it. It employs gradient boost decision tree with a built-in regularization to prevent overfitting, ensuring that every single subtle relationship between macroeconomic variable sentiments, indices, and market indicators are accurately captured. Light gradient boosting model act as a meta learner integrating the prediction generated by LSTM XGBoost to produce the final refined output. It is high computational efficiency and leaf wise tree growth algorithm enables switches convergence while maintaining precision across multiple training iteration that enable configuration balance between the temporal sensitivity, nonlinear generalization, and computational efficiency. Optimization framework, which is the hybrid performance that further enhance dual layer optimization process combining the NSGA2 algorithm and Adam optimizer. Now, NSGA, which is the non-dominant sorting genetic algorithm. This evolution algorithm performs multi-objective hyperparameter optimization simultaneously minimizing both mean square error and mean absolute error. Adam optimizer. During modeling training, the Adam optimizer dynamically adjusts the learning rate, uses the momentum-based gradient estimation, promoting faster convergence and avoiding local minima. This adaptive approach guarantees smoother gradient descent even in high non-convex optimization landscape, typically of a financial and economical data. Dual objective and learning efficiency. The hybrid system was designed across dual optimizing objective to minimize both MSE and MAE simultaneously. While MSE penalizes large deviation more strongly, MAE ensures overall forecasting consistency. Together, they form a robust loss function that enables the model against outliers and structural breaks. So in an essence, this architecture combines the sequential intelligence of by LSTM, the structural depth of ensemble learning, and the precision of an evolution optimization, creating a framework that is technically sophisticated, computationally efficient, and empirically validated from complex economic forecasting. Results and discussion and the key findings. So the proposed key empirical finding derived from the implementation, testing, and evaluation of the proposed hybrid forecasting framework has resulted and validated both the theoretical premise and the methodological innovation of the study that integrates deep learning, ensemble methods, and multi-object optimization can substantially improve forecasting accuracy and stability under condition of high economic uncertainty. So the superior model performance, the proposed hybrid model, which integrates the by LSTM, execute, and light GBM, achieves super predictive accuracy compared to traditional economic and behavior AI model. This combination effectively leverages the temporal learning capability of by LSTM, the nonlinear features interaction handling of XGBoost, and the computational efficiency of light GBM. Together, they produced a cohesive system capable of learning complex dependency within the time series data and maintaining generalization across different time horizons. The evaluation metrics. In quantitative terms, the hybrid model attained an R2 square of approximately 0.995, signifying near perfect alignment between predicted and actual values. So this metric confirmed that the model successfully captured nearly all the variance inherent in the economic time series, outperforming single model and unoptimized ensemble baseline. So furthermore, error metrics include MSE, MAE, root mean square error, and mean absolute percentage error, all the recorded extremely low values indicating exceptional precision and reliability. So for an instant, MAP of just 3.39 suggested that an average the model predicted deviate by less than 4% from observed outcome, an achievement rarely observed in macroeconomic forecasting model. And then optimization of the model and the stability. So the NSGA2 optimization algorithm significantly enhanced the model typically observed during training, the smoother learning curves in volatile data environment. So this improvement was particularly evident that during the high volatile period, such as market correction and post-pandemic rebounds, when traditional models struggle to maintain stability. And the results the collectively affirms that the proposed framework not only achieve technical excellence but offers practical utility for policymakers and corporate decision makers, such as precision and reliance translate into more reliable forecast for investment planning, risk management, and macroeconomic policy formulation. Moreover, enabling AI layers, the framework addresses one of the most persistent challenges in AI based forecasting, which is the black box problem, ensuring that its prediction can be interpreted, justified, and acted upon responsibility. So modern interpretability and explainability. This slide illustrates one of the most important contribution of this research, the integration of explainable artificial intelligence method to make the hybrid model transparent, interpretable, and trustworthy for managerial and policy application. While high accuracy is essential, it is equally critical that the decision makers understand why and how a prediction was made. Therefore, this study employs two complementary explainability techniques: SHAP, which is a sharply adaptive explanations, and LIME, local interpretable model agnostic explanation, to analyze both global and local model. So SHAP, the first chart in the upper right section, represent the summary plot which quantifies the contribution of each features and model components to the hybrid system overall prediction. The SHAP value shows that both by LSTM and exhibit play a critical but distinctive role in the predictive process. So the BiLSTM component is emerge as a dominant contributor, but long-term temporary dependencies, cyclical patterns, and the lagged effect across the time series. So in contrast, exhibits component complements BiLSTM by standardizing short-term fluctuation, capturing non-linear interactions, and adjusting for local anomalies in the market condition. Hence, these findings confirm that the hybrid architecture functions are intent with bi-LSTM modeling and sequential economic behavior and execute refining predictive granularity. The sharp distribution indicate that the sharp values in red correspond to a period of strong positive influences on forecast accuracy, while low value in blue represent marginal or stability effects. Lime local interpretability. The second and the third visualization presents the Lime local explanation result, providing case level interpretability, while Sharp offers a global understanding of model average. And here Lime demonstrate that when by LSTM influence exceed a certain threshold greater than 1.5 is exert a dominant positive effect on the output. Meanwhile, exhibits contributes to around 0.99, complementing the YLSTM by defining prediction during local volatility. This research framework transformed the hybrid model from black box into a glass box, enabling users to trace and justify prediction with empirical transparency. For research, it enhances theoretical understanding of model behavior, and for policymaker, it is providing the trust and accountability, ensuring that the AI-based forecasting can be confident and used for strategic decision. Ultimately, this decision of Sharp and Line proves that the accuracy and explainability can coexist, positioning the proposed framework as a robust and ethical AI solution for modern economic forecasting. Comparative evaluation. This slide focus on the comparative evaluation conducted to test the effectiveness of the proposed hybrid AI forecasting framework, combining LSTM plus XGBoost plus Light GBM with the optimizer proposed in the research, and it compared with the other hybrid models. The purpose of this analysis was to determine how the inclusion of multi-objective optimization and meta-learning integration improve forecasting performance relative to other hybrid configuration. So comparative design. To ensure robustness and fairness in the evaluation, three different hybrid model configuration were tested using the same data set and performance metrics. So the proposed model is the LSTM plus XGBoost plus Light GBM with NSGA optimizer, which represent the full implementation of the study framework. And then the hybrid baseline one, which is the LSTM plus XGBoost and rigid without the optimizer, and then LSTM, XGBoost, and Light GBM without optimizer, along the direct comparison to isolate the contribution of optimization. So each model were evaluated under identical experimental condition using key metrics such as R2 square, MSE, MAE, RSME, and MAPE to quantify accuracy, robustness, and stability. So the comparative result demonstrate a clear performance hierarchy within the proposed model, achieving a R2 square or R square of 0.9949 and the lowest error metrics across all category. The comparative analysis reinforced one of the central argument of this research, that the AI forecasting system achieve optimal performance when deep learning and ensemble models are complemented by evolutionary optimization. By balancing multiple learning objectives simultaneously, the NSG to optimizer ensure that the model maintain both predictive decision and resilience essential for application. So this slide presents the baseline comparative performance of a hybrid forecasting model combining LSTM, XGBoost, and rigid regression, implementing without optimization. So the performance visualization on the left-hand side, we can see that the actual versus predicted Tesla stock price were over the full time series. The blue line represent the actual observed prices, while the orange dotted represent the predicted prices generated by the baseline hybrid model without so while the overall trend alignment is acceptable, there are visible deviation during period of sharp volatility, particularly in the mid and late time step, indicates that this non-linear optimizer model struggles to adapt to sudden regime shifts and non-linear transition. So quantitative results on the right hand side, the table summarize evaluation metrics for this configuration. R2 square of 0.8972, which indicates that approximately 89.7% of the variance in actual price is explained by the model. MSC for reflecting the moderate error magnitude, RSME of 0.0003, suggesting relatively low error depression per prediction, MAE 14.466, meaning that the average deviation between the predicted and actual price is about 14 units, and the MAP 3.39%, which is representing a low but optimal percentage error relative to the total magnitude of the observed prices. So the metrics collective shows that while LSTM exhibit enriched model performs reasonably well, it lacks the fine-tuned adaptability needed to manage high-frequency fluctuation and non-linear dependency. The rigid regression layer, while stabilizing the overall trend, is insufficient in capturing short-term dynamics correlation correction, which will be later addressed in the introducing Light GBM as a meta learner and NSG to optimization in the proposed model. Thus, the key takeaway from these baselines serve as an important control experiment, demonstrating that the hybridization alone do not guarantee optimal result. Only through evolutionary optimization and meta-learning enhancement can the model achieve the precision and resilience required for a real economic forecasting under uncertainty. So the actual versus predicted stock prices. This slide present the second baseline configuration, which is a three-layer hybrid model. Again, LSTM, XGBoost, and Light GBM without any optimization algorithm. So the graph on the left shows that the actual versus predicted Tesla stock prices across the observed time step compared to the real earlier baseline that exhibits the tighter overlap between the actual and predicted price line. The light GBM layers add predictive weighing to the ensemble output, resulting in smoother transition and improved response to the market fluctuation. However, some deviations remain visible during the sharp price spike, indicating limited adaptability in extreme volatility condition as an aspect addressed later through the energy and optimization process. On the right hand side, the table provides statistical evaluation result. R2 square of 0.594, MSE of 1.58.0389, showing a significant reduction in mean squared error, indicating tighter prediction clustering across the two values. Again, RSME of 0.003, MAE of 9.3402, MAP of 4.02, which is slightly higher than the rigid phase model, but still within the acceptable forecasting units. So the interpretation from these results confirm that introducing the light GBM enhanced nonlinear generalization and ensembling the integration outperforming the rigid variant in both precision and consistency. However, since this model lacked optimization, it is still experiencing insufficiency in hyperparameter tuning and the local minima convergence. Consequently, while accuracy improved, the model remained suboptimal in balancing error trade-off across volatility regimes. And the key insight what we take is that the experiment demonstrated the hybrid deep learning ensemble architecture alone are powerful but insufficient without optimization control. So in the next slide, we can incorporate NSG to optimization to further refine parameter search, yielding near perfect alignment between predicted and actual values, representing the final proposed model of this thesis. So this is the actual versus predicted. The slide represents the final proposed forecasting model, which integrate LST, XGBoost, and Light GBM optimized through the NSGA2 evolution algorithm. This architect represents the complete version of the hybrid framework design in this research, combining deep temporal learning, nonlinear ensemble integration, and multi-objective optimization for superior predictive accuracy and interpretability. So the model visualization on the left plot indicates the actual versus the predicted Tesla stock over the test period. Here the orange predicted the line almost perfectly overlapping the blue, almost an actual price line demonstrating exceptional alignment and zero near deviation across both stable and volatile market segment. Unlike the prior non-optimized model, this configuration exhibits non-significant lag in responsive to regime shift, providing that the optimizer has successfully calibrated the hyperparameters to minimize the overfitting and underfitting simultaneously. On the right-hand side, the R2 square of 0.9949 indicates near perfect correlation between predicted and actual pricing. MSC effectively 0.0000, showing negligible variance between predicted outputs and the true values. RSME of 0.0003, signifying minimal depression and outstanding consistency. MAE of 0.0002, representing extreme low mean absolute deviation across prediction. MAP, which is of 3.39, an excellent accuracy level, especially considering the high level frequency and nonlinear nature of the shock data. So the result clearly demonstrated that the multiple objective optimization via NSGA2 significantly enhanced model performance. By balancing the objective of minimizing both MSE and MAE, the optimizer enhances both robust generalization even under the extreme volatility. This conversion enables the model to self-adapt to complex temporal dynamics, delivering both precision and reliability and the key requirements of the modern economic forecasting system. So in summary, the proposed AI-driven optimization enhanced hybrid model achieves state-of-art forecasting accuracy, outperforming all baseline configuration. It proves that the integration, deep learning, ensemble learning, and evolution optimization within a single explainable framework can fundamentally advances economic cycle prediction and real-time financial decision support. So this is the model comparison. So the slide provides a consolidated comparison of the three hybrid model developed and tested through the research. The visualization score compared R2 score and the mean absolute error across the three configuration, namely all that was discussed in the previous three slides. So the observation from the chart is that the result clearly demonstrate a progressive improvement across the each iteration of the model developed. In the rigid plus no optimization configuration, the R2 value is relatively lower and MA is significantly higher, reflecting poor adaptability to nonlinear and volatile market condition. Introducing the light LGBM as the meta learner enhance predictive stability, reducing the MAE and improving R2 square, which shows that the ensemble integration alone contributes significantly to model robustness. And then the proposed optimized model achieved the best overall performance with the highest R2 square of 0.995 and the lowest MAE approaching to nearest zero error margin. So in summary, the comparative chart visually reinforces the key contribution of this thesis. The optimization-driven hybrid AI architecture outperforms the conventional and semi-hybrid forecasting model by a significant margin, both in accuracy and reliability. Key performance matrix. The R2 square of 0.9949 indicates an exceptionally strong explanatory relationship between predicted and actual stock prices. This near perfect alignment signifies that the model accounts for almost all variability in the data, a clear sign of excellent model fit. In practical terms, it implies that the AI-driven framework successfully captured both the trend and the volatility components inheriting in the Tesla stock series, confirming the reliability and temporal learning capability. MSE of exactly zero, meaning that the model predicted output deviation minimally from observed value. Hence, it also reinforces that the ensemble and optimization synergies achieved a stable convergence throughout the training and validation cycle. MAPE, mean absolute percentage error of 3.39 represent that an outstanding level of forecasting accuracy for high frequency financial data. This means that on average the model predicted deviate less than 3.4% from actual outcome, a remarkable improvement over both baseline configuration in economic forecasting contexts. MAP below 5% is considered highly reliable for policy investment and managerial approach. So overall, these metrics collectively confirm that the proposed AI optimized hybrid framework outperforms all benchmark model. It delivers exception predicted accuracy, error minimization, and generalization stability, even when they're exposed to real world volatility. So explaining the AI integration, this slide illustrates the integration of AI into the forecasting framework, a critical component that bridges model accuracy with interpretability, trustworthiness, while AI models such as by LSTM and XGBoost achieve the high predictive analysis. Their black box nature often limits their applicability in managerial and policy contexts. To address this, the framework employs two complementary explainability AI techniques such as SHAP and line. Business cycle explanation. So this slide represents the practical application of the proposed AI-driven forecasting framework, specifically focusing on how accurate business cycle prediction can be support investment, market strategy, and policy formulation. The strength of this research lie not only on the methodological innovation, but also in the ability to provide actionable insight for the decision makers across sectors, investment timing, market expansion, policy formulation. So in summary, these applications illustrate how this research bridges the gap between AI innovation and managerial utility. The framework not only advances academic understanding, but also provide a data-driven decision support mechanism, empowering investor, cycle, and policymaker to act proactively rather than reactive in navigating economic cycles. So this slide illustrates one of the core methodological strengths of this research, the integration of multi-source data stream to enhance the robustness and contextual awareness of the business cycle forecast. Traditional economic model often rely on narrow set of structured indicators such as GDP, inflation, or interest rate, which are published frequently but lag behind real economic activity. In contrast, the proposed AI-driven framework incorporate high-frequency, heterogeneous, and real-time data source, allowing for faster detection of economic shift and regime change. So the news sentiments. The first dimension involved real-time analysis of economic news for reliable sources such as Reuters, Bloomberg, central bank bulletins. Natural language processing techniques are used to extract positive, negative, or neutral sentiment for these new articles, providing early warning signals about the market optimism, policy uncertainty, or investor confidence. These sentiments help anticipate movement before they appear in the official statistics. Financial market, which is the high frequency market data, allowing the model to reflect real time shift to in risk perception and liquidity condition. Social media, which is the platform like Twitter, Reddit, LinkedIn, have become major conduits for investor sentiment for public discourse. Uh, Hence, the grassroots level behavior signal that often precede large scale market reaction. This unstructured data add a behavioral economic layer to a traditional forecasting model. Satellite data, such as direct proxy of real world output and consumption pattern, incorporating these variable improves the spatial and temporal granularity of the forecast, particularly for developing or data sparse region. And finally, supply chain data, which is the real-time logistics and inventory data from global supply chain, provide insight in production trend, demand fluctuation, and inventory cycle. So these variables ensemble the model to identify disruption of and recovery earlier than conventional macro indicators. So practical implementation. This slide summarizes the practical and stakeholder-specific benefit that emerge from implementing the proposed AI-driven business cycle forecasting framework. While the previous section focused on methodological rigor and model validation, this emphasizes how system translate into real world value for three primary stakeholders, which is the investor, business makers, and policy makers. So investors, uh, the model ability to forecast economic turning points with high precision, superior risk management, and optimal portfolio timing, accurate cycle prediction to allow investor to reallocate asset before market transition. So ultimately, the model support enhanced return optimization by aligning the investor strategies with empirical validation macroeconomic signal. For business strategic planning tool, it offers data-driven insight into when and to expand production, enter new market, or adjust resource allocation. For instance, firm can synchronize supply chain operation and market campaign with anticipated economic expansion or contraction, minimizing inefficiencies. For policymaker, it contributes to the evidence-based economic governance. In an essence, the model bring the gap between AI innovation and actionable intelligence by simultaneously serving the need of investor business policymakers, multi-layered decision support ecosystem that enhance economic foresight, strategic agility, and institutional stability. So the research and limitation and future scope, current limitation, the first limitation, what I understand is to single asset focus of this study. The data set used is the Tesla stock from 2010 to 12, serve as a control proxy for real world financial dynamics. However, it limits the cross sector generalizability of the finding. Additionally, due to the computational complexity of hybrid deep learning and ensemble framework, model training demands high performance hardware, making real-time scalability challenges in resource constrained environment. Second is the multi-asset extension. Future research should expand the framework beyond a single asset or single sector focus, applying this hybrid AI economic model to multiple industries such as manufacturing, energy, logistics. Macroeconomic indicators like GDP and inflation would enhance external validity and demonstrate the model cross-domain adaptability. And which the third is the advanced architecture, which is state-of-art deep learning architecture, particularly transformers and temporal fusion transformers. So this model excel along sequence learning and dynamic attention weighing, which could further improve the temporal interpretability and performance. Real-time implementation, which is the live such system would serve as an intelligent decision support dashboard for policymaker, investor, and corporate strategies, allowing rapid response. So, in conclusion, while the current model demonstrates high accuracy and interpretability, future research will focus on expanding its scale, computational efficiency, and real-time compatibility. Um, so key contributor for this research thesis is the methodological innovation, which is the first and the significant contributor which lies in under the methodological innovation, the superior performance, and then which has achieved the 99.4902 square, and then transparent decision making, which is um, what the forecast is, thereby reinforcing trust, interpretability, and compliance in high-stake decision-making environment. So, in essence, this research contribute a novel hybrid AI forecasting framework that is technically robust, empirically validated, and ethically transparent, setting a foundation for future advancement. So, of course, the last slide, which is the future, which is predictable. As I conclude this presentation, I would like to return to the central theme that inspired this research, the pursuit of predictability within economic uncertainty. So this study demonstrated how AI-driven hybrid framework can fundamentally transform the way we understand, forecast, and respond to economic dynamics by integrating multiple source data, advanced optimization algorithm, and explainable artificial intelligence. The research provide a pathway to merge predictive accuracy with interpredictive transparency. It moves beyond the limitation of conventional economic model, not only predicting the next phase for the business cycle, but also explaining why and how such shift occur. So this framework serves as a bridge between academic rigor and managerial application. It translate complex artificial intelligence architecture into actionable insight for investor, business leaders, and policymakers, enabling informed strategies, decision grounding in empirical intelligence where decisions are not driven by speculation but by significant scientifically explainable forecast. So, in an essence, the message is simple yet profound. The future is predictable, where intelligence is explainable. This research provides that when we combine transparency, adaptability, and computational intelligence, we move more closer to mastering the complex rhythm of the global economy. And then, thank you for your time and attention to this research.